Hello everyone and welcome. Today we're going to dive into a topic that I believe is becoming increasingly critical for anyone working with data and needing to communicate insights effectively: automated presentations. We're here to explore the blueprint for automated presentations, and more specifically, a developer's guide to programmatic slide generation. Think of this session as laying out the architectural plans for a new, more efficient way to build your most impactful presentations. Have you ever found yourself manually updating a dozen slides because the underlying data changed? Or perhaps you've wished you could apply consistent branding and layout across hundreds of reports without endless clicking and dragging. If so, you're absolutely in the right place. This guide is designed for developers, data scientists, and technical managers like yourselves. We'll show you how to build robust, data-driven pipelines that generate reproducible presentation assets, fundamentally transforming how you create and share your work.
All right, so we've established the blueprint for automated presentations. Now let's talk about the why and the how it transforms your workflow. How many of you dread the manual effort involved in creating routine reports, personalized sales decks, or updated product catalogs? The endless cycle of copy-pasting, screenshotting, and version control can be a significant drain on valuable technical time. It's time to move beyond manual work and embrace the power of data-driven presentation pipelines. This isn't just about shaving off a few hours. It's about enabling programmatic generation to unlock truly powerful automation workflows. We're talking about creating assets that are inherently reproducible, massively scalable, and always live data integrated. Imagine your presentations building themselves, reflecting the absolute latest data without a single manual click. This paradigm shift opens up incredible possibilities across your organization. Think about, first, automated reporting, where weekly reports literally build themselves from your live data sources, freeing up your team for deeper analysis. Then, personalized content, batch creating hundreds of branded slides tailored to individual clients or campaigns directly from a spreadsheet or database. Third, generating entire product catalogs or portfolio overviews automatically, ensuring accuracy and consistency across all materials. And finally, turning your interactive analytics dashboards into dynamic dashboards that can be shared as recurring professional slide decks, making your insights accessible to everyone. These are just a few compelling examples of where programmatic presentation generation shines. On the next slide, we'll dive into the 4 proven pathways that allow us to achieve these outcomes.
So we've talked about why automating presentations is powerful, saving time, ensuring consistency, and creating truly data-driven narratives. But how do you actually achieve this? That's where these 4 proven pathways for programmatic generation come in. We've explored the landscape of presentation automation and distilled it into these major blueprints. Each offers a powerful toolset specifically designed to align with your existing technical stack, your team's unique collaboration needs, and your desired distribution models. There's no one-size-fits-all, but rather a spectrum of robust options to choose from. First, for all the Pythonistas and data scientists, we have the Python path, leveraging versatile libraries like Python PPT to build presentations directly from your scripts and data. If JavaScript is more your speed, whether for front-end web apps or back-end Node.js services, the JavaScript path with PPTXGen.js offers fantastic browser-based or server-side solutions for creating PowerPoint files. For those embracing cloud-native infrastructure and deep integration, the cloud-native path, exemplified by the powerful Google Slides API, is ideal for truly scalable, collaborative, and web-integrated presentation generation. And finally, for those who prefer web-first, markdown-driven presentations with incredible flexibility and version control, the web-based path with tools like Reveal.js and MARP is a game-changer. Over the next few slides, we're going to dive deep into each of these blueprints, starting with a closer look at the Python path and Python PPT.
All right, now that we've outlined the 4 major programmatic generation pathways, let's dive into our first blueprint: generating presentations locally using the Python-PPTX library. This library is truly the de facto standard for Python-based PowerPoint generation. It's robust, well-maintained, and widely adopted, making it a reliable choice for countless projects. One of its key strengths is its ability to create native OOXML-compliant .pptx files directly. What does OOXML-compliant mean? It means the files are truly native, fully editable, and can be opened by any modern PowerPoint application, all without requiring Microsoft Office to be installed on the machine running the script. This makes Python-PPTX incredibly versatile and allows it to work cross-platform, a crucial feature for headless environments like servers, Docker containers, or cloud functions where you wouldn't have Office installed. Consequently, it's ideal for data science and back-end automation pipelines, where you might be generating reports, dashboards, or hundreds of customized presentations based on data, all programmatically. So, how simple is the basic workflow? It follows a straightforward mantra: create, populate, save. As you see in the code example on the right, first, we create an empty presentation object. Then we add a slide, selecting a specific layout, like a title slide, and access its elements, such as the title shape. We then populate that title shape with our desired text, for instance, Hello World. And finally, the prs.save method writes your brand new .pptx file directly to disk. It's a clean three-step process to generate a complete, editable PowerPoint file. In the next slide, we'll explore some common use cases and detailed workflows for Python-PPTX, showing you how you can leverage this powerful library in your own projects.
All right, so we've covered the basics of Python PPTX for local presentation generation. Now let's dive into some of the most common and impactful use cases that truly highlight its power in automating workflows. First up, and probably the most frequent enterprise scenario, is automating reports directly from CSV or Pandas data frames. Think about generating monthly or quarterly reports with dynamically updated charts, tables, and textual summaries, all driven by your latest data. Python PPTX makes this incredibly straightforward. On the right, you see a Python code snippet demonstrating this. We import pandas for data handling and chart data from Python PPTX. After loading your data into a data frame, you simply map that data to a chart data object, defining categories and adding series like sales data. Then with a single command, slide.shapes.addChart, that dynamically generated chart is inserted into your PowerPoint slide. This ensures data accuracy and consistency, eliminating manual updates. Another extremely valuable workflow is template-based placeholder replacement. For organizations with strict branding or needing consistent messaging, you can design a PowerPoint template with specific placeholders. These act like merge fields, such as client name or report date. As the diagram illustrates, you load this pre-designed template and then programmatically replace these placeholders with your dynamic content, perhaps client ink for a specific report. The key benefits? The new content automatically inherits all the formatting from the original placeholder, ensuring brand compliance without extra effort. These two examples showcase the robust capabilities of Python PPTX within a Python ecosystem. But what if your automation needs extend beyond a Python-only environment, requiring a more cross-platform or client-side approach? That's precisely what we'll explore with our next blueprint, introducing another powerful tool for presentation generation. After exploring the Python ecosystem with Python PPTX, let's shift gears to a JavaScript-based solution. Blueprint 2, Cross-Platform PPTX with PPTX.js. This library is a fantastic option for those working within the JavaScript world, offering immense flexibility. At its core, PPTX.js stands out as the most mature JavaScript library for generating PowerPoint files. What makes it truly cross-platform? It boasts full support for Node.js environments, perfect for server-side automation, but critically, it also runs directly in browsers via a CDN and integrates seamlessly with modern JavaScript frameworks like React,
Angular, and Electron for desktop applications. Developers will appreciate its zero runtime dependencies and full TypeScript definitions, which lead to a much smoother development experience. Now let's look at some key differences in its behavior across environments. When you call write_file in Node.js, it predictably saves the presentation to your local file system. But in a browser, it cleverly triggers a client-side file download for the user. Similarly, for image handling, Node.js can work with local file paths, while in a browser, you'll provide URLs for web-hosted images or embed them directly using base64 strings. To illustrate, consider the browser example on the right. Here, we instantiate pptx.js, add a slide, and then dynamically add text using data from a simple JSON object, defining its position and font size. The critical step for client-side use is the pptx.writeFile call with a file name parameter. As the arrow indicates, this action initiates a client-side file save, allowing the user to download the generated report.pptx directly from their browser. This client-side capability makes pptx.js incredibly powerful for interactive web applications or internal tools where users generate reports on demand. But what if your automation needs extend to collaborative cloud-native environments? On our next slide, we'll explore Blueprint 3, Cloud-Native Collaboration with the Google Slides API. Moving from local cross-platform generation, our third blueprint dives deep into cloud-native collaboration using the Google Slides API. This approach is ideal when your automation needs to be tightly integrated with the Google Workspace ecosystem. Think about it. You get built-in real-time collaboration, cloud storage, automatic version history, and seamless drive sharing. It's about leveraging Google's infrastructure directly rather than just generating a static file. Of course, getting started requires a Google Cloud project setup and proper OAuth authentication to secure access. Now, for the key workflow with the Google Slides API, it's all about batch operations. Instead of making individual API calls for every single change, like replacing text here, inserting an image there, you can send batches of update requests in a single call. As you can see in the example code, we define multiple replace all text requests, package them into a requests array, and then execute them using batch update. This is the most efficient way to interact with the API, especially when dealing with complex or repetitive tasks. And speaking of efficiency, the Google Slides API does have rate limits: 60 requests per user per minute and 300 requests per minute per project. This is precisely where batch operations become indispensable. By consolidating multiple changes into a single API call, you dramatically reduce your request count and easily stay within these limits, ensuring your automation runs smoothly. This blueprint offers powerful integration for collaborative environments. But what if you crave even more direct control over the presentation's structure, perhaps using open web standards? That's what we'll explore next. Moving on from the power of cloud-native APIs for collaborative slide decks, let's explore Blueprint 4, Version Control and Customization with HTML. What if you want to treat your entire presentation as a software project, from its core structure to its dynamic interactions? This blueprint empowers you to do just that by truly treating your presentation as code. This is a game changer for several reasons. It's perfect for robust version control using tools like Git, enabling seamless team collaboration, clear change tracking, and easy rollbacks of your entire presentation history. You gain full customization by leveraging standard web technologies, CSS for intricate styling, and JavaScript for dynamic interactivity. This makes it ideal for code-heavy presentations where you might need to embed live demos, interactive charts, or complex visualizations directly into your slides. When it comes to building presentations with HTML, there are generally two main flavors you might consider, depending on your preferred workflow and level of control. First, we have Reveal.js, which we categorize as the framework-first approach. As you can see from the code snippet on the left, it leverages a standard HTML structure. You define your individual slides using section tags within a main div, and Reveal.js handles all the presentation logic. This gives you maximum granular control over every element, transition, and interaction. It's a hugely popular and powerful framework, boasting over 67,000 stars on GitHub, making it a go-to for developers comfortable with web technologies. On the other hand, we have MARP, offering a Markdown-first approach. If you prefer writing content over structuring HTML, MARP is your simplest and fastest path. As shown in the example on the right, you simply write your slides in clean, intuitive Markdown. MARP then renders this into beautiful presentation-ready slides, and crucially, it offers native PDF and even PowerPoint (PPTX) export options, making it incredibly versatile. It's a fantastic choice for data scientists or engineers who want to quickly generate professional slides directly from their Markdown notes or reports. So whether you seek granular control with a robust framework like Reveal.js or rapid content creation with Markdown-based MARP, HTML provides a powerful developer-centric foundation. But now that we've covered how to build and manage these code-driven presentations, how can we automate the generation of their content? That's the perfect lead-in to our next blueprint, where we'll explore integrating AI and large language models for automated content creation. So far, we've covered how to control the structure and layout of our presentations. But what about the actual content? How can we leverage AI to generate that dynamically and reliably? This slide introduces our Integrator module for AI-powered content generation. The process begins with a clear prompt for our LLM, which then initiates an LLM API call. The critical step highlighted here is the structured JSON output. Instead of free-form text, we instruct the LLM to return data, like a slide title and bullets, in a precisely defined JSON format. This structured data is then fed into our rendering library, such as Python PPTX or PPTX.js, culminating in a final .pptx file. This approach champions a clear separation of concerns. AI excels at synthesizing information. Presentation libraries handle visual rendering. By using structured outputs, we guarantee valid data that directly maps to our rendering code, cleanly separating the AI provider from the presentation library. A practical example is defining a Pydantic slide model in Python with a title and bullets. We then use OpenAI's API, explicitly setting response model equals slide. This tells GPT-4.turbo to strictly adhere to our schema, returning a validated slide object that's immediately usable by Python PPTX without additional parsing or validation. As a bonus, remember you can integrate DALL-E or similar APIs to generate images programmatically, inserting their URLs or base64 data directly. This robust content generation capability truly completes our toolkit. Next, we'll shift to a comprehensive feature comparison across all 4 blueprint pathways, helping you identify the best approach for your specific automation needs. So, once you've leveraged AI to generate your core content, the next crucial step is how you translate that into a presentation format. This master schematic lays out the key features across different automation pathways we've discussed, helping you identify the right tool for your specific needs. Let's break down the capabilities of Python PPTX and PPTX.js for code-driven generation, the Google Slides API for cloud-based automation, and Reveal.js or MARP for HTML-based presentations. First, offline support. For many enterprise or data science contexts, local execution without internet dependency is non-negotiable. Here, Python PPTX and PPTX.js excel, as do HTML-based frameworks like Reveal.js or MARP. The Google Slides API naturally requires connectivity. Conversely, if human intervention and real-time collaboration are part of your workflow after initial generation, Google Slides API is the clear winner. The others are fundamentally single-user generation tools. For native chart generation, which is often central to data-driven presentations, the Python and JavaScript libraries offer robust capabilities, generating editable charts directly within PowerPoint. Google Slides has some support, but it's often more challenging to integrate custom data dynamically, and HTML-based tools typically embed images or use web-based charting libraries, which aren't truly native PowerPoint charts. Template editing is critical for maintaining branding and consistency. Python PPTX excels here, allowing fine-grained control over existing templates. PPTX.js and Reveal.js/MARP offer flexibility, but might require more custom coding. Google Slides is good if you're comfortable with its template system. Direct PDF export is straightforward with cloud platforms like Google Slides or HTML-based frameworks. Python and JavaScript libraries can generate PPTX files, but converting them to PDF often involves an extra step or tool, hence the warning. A significant consideration for heavy automation with the Google Slides API is API rate limits, which can cap your generation throughput. The other solutions, being local or self-hosted, don't face this constraint. And crucial for our audience, Git-friendly version control. HTML-based presentations using Reveal.js or MARP are inherently text-based, making them perfectly suited for Git. The Python and JavaScript libraries, while their code is version-controlled, generate binary .pptx files which are not ideal for Git diffing. Google, as a cloud service with binary files, struggles significantly in this area. As you can see, each pathway has its strengths and weaknesses, depending on your priorities for collaboration, offline capability, native features, and developer workflow. This table should help you start weighing these trade-offs. On our next slide, we'll dive into a decision framework to guide you through selecting the ideal approach for your specific use case. Now that we've explored the unique capabilities of each approach, let's bring it all together into a decision framework. This slide helps you pinpoint the best pathway for your specific context based on your team's existing tech stack, project goals, and your audience. First up, Python PPTX. This is your go-to if you're deeply ingrained in Python for back-end automation or data science pipelines. If your requirement is to churn out reports directly from Pandas data frames, or you need high-volume offline generation without any API limits, Python PPTX offers a robust, scalable, and entirely self-contained solution. On the flip side, for our JavaScript and TypeScript developers, we have PPTX.Gen.js. If your project thrives in the JavaScript and TypeScript ecosystem, whether it's Node.js on the back end or a front-end application, and you need to generate presentations directly in the browser or within a React, Angular, or Electron app, PPTX.Gen.js integrates seamlessly into your workflow. Then there's the Google Slides API. This pathway truly shines when real-time collaboration and team access are paramount, and you're already deeply integrated into the Google Workspace ecosystem. If your current workflow involves copying master templates and dynamically replacing text, the Google Slides API provides familiar tools with powerful programmatic control. Finally, for the most technically inclined, consider HTML with Reveal.js or MARP. This approach is ideal when the presentation itself needs to be version-controlled with Git, your audience is primarily developers, and the content is code-heavy. It's perfect for embedding truly interactive elements like live code editors or videos, offering a level of customization and engagement unmatched by traditional slide formats. So as you weigh these options, think about your primary use case. Which environment are you most comfortable in? What are your key non-negotiables? Offline generation, browser integration, collaboration, or deep code focus? Once you've chosen your path, we'll turn our attention to the best practices for building solid, maintainable automated presentations, ensuring your efforts lead to lasting success.
So once you've chosen your pathway for automated presentation generation, how do you ensure the presentations produced are not just functional but truly excellent? The answer lies in these best practices, your blueprint for building a professional, consistent, and easily maintainable system.
First, and critically, start with templates. Never build from a blank canvas. Whether you're using Python PPTX, PPTX.js, or the Google Slides API, always leverage pre-designed master slides or existing .pptx files. This ensures your brand guidelines are implicitly followed, drastically reducing manual styling and boosting consistency across all your outputs. Next, embrace constants for styling. Just as you define variables for data, centralize your brand colors, fonts, and common positions in a configuration file. This eliminates magic numbers in your rendering code, making updates trivial and vastly improving maintainability. Imagine changing your brand blue in one line of code and it propagates everywhere. Third, make your templates smart with placeholders. By using constructs like client name, the content you inject automatically inherits the correct formatting from your template. This eliminates a huge amount of boilerplate code, ensures visual consistency, and drastically reduces styling errors. Finally, and critically important when integrating large language models, validate your AI outputs. Don't just trust raw LLM text. Structure your prompts to constrain length and format. Think max 5 bullets, max 10 words per bullet. Then, crucially, validate the resulting JSON against a defined schema before rendering. This safeguards against unexpected outputs, ensures data integrity, and keeps your automated system robust and predictable. By adopting these foundational practices, you're not just automating a task, you're creating a robust, scalable, and truly reproducible system. This is where presentations stop being one-off documents and start becoming valuable data-driven assets. And that brings us to our conclusion. We've explored the best practices for building robust automated presentations. Now, let's tie it all together and truly appreciate the profound shift this represents. Your presentation is no longer just a static file, it's now a reproducible, data-driven asset. Think about it. Programmatic generation completely transforms presentations from a manual, often tedious design task into a robust, fully automated pipeline. No more dragging and dropping elements manually every time your data changes or a requirement shifts. It all starts with your content. This isn't just text on a slide, it's structured data living in databases, accessible via APIs, or dynamically generated by AI models, often in a standardized format like JSON. This content then feeds directly into a powerful rendering engine. Here, you have incredible flexibility. Whether you prefer coding in Python with libraries like Python PPTX, leveraging JavaScript with PPTX.js, integrating directly with platforms like Google Slides, or generating pure HTML5 for web-based presentations, the engine adapts. The ultimate benefit? Maximum flexibility and efficiency. Imagine being able to swap out an AI provider without needing to redesign a single slide. Or generating multiple output formats, a PowerPoint deck for a live presentation and an HTML version for web publishing, all from the exact same content engine. This isn't just about automation, it's about shifting your mindset. You now have the blueprint to build, automate, and truly scale your presentations as code. Are you ready to embrace this future and transform your presentation workflow?